Hi guys, welcome to another Learning Electronics Repair video. This one might be quite easy actually. It's an amplifier, Ibiza Amp 800. Switch is hanging out of it. And it doesn't seem to be the original switch, doesn't seem to fit. And I also notice that the fan looks a bit clogged up in the back of this as well. Let's have a look. Oh god, that's solid, yeah. And the guy who asked me to look at this, one of the local bars, said that it runs for a while and then shuts down, but now it doesn't switch on at all. So let's have a look and see what the problem is. I think I've figured out the reason why it runs for a while and shuts down, because the fan's seriously clogged up. But I'm not sure about that doesn't switch on at all anymore. So let's have a look to see what's happened to this. Maybe it's overheated and something's died a death inside here. Possible. Looks like a few of the screws are missing already. Doesn't surprise me with stuff and board here. They have a hard life, yeah. So let's take this out. This is another Power Sound local company who were in the same commercial centre as my workshop. Well, about a month or so ago, I noticed that their shop is all closed down and empty, and all the signs have gone. So I don't know whether that means they've stopped trading or whether they've just moved to somewhere else, maybe somewhere better or somewhere cheaper, possibly. So let's just get the rest of these screws out of this. Okay. Is it? Oh yeah, that's it. Oh. Okay. Well, it's full of dust and dirt. This is the amplifier itself. I suspect there's probably power devices on both sides. So here and yeah, you can kind of see them if you look down there. So power devices both sides. Quite often, one side of the heatsink will be all the positive side output transistors, and the other will be all the negative side. I'm assuming this is like a linear amplifier, not one of these Class D amplifiers. It looks like a linear amplifier. Two transistors, pardon me, two large capacitors, one on each rail, a relay, a transformer, linear, bridge rectifier. Looks like a little voltage regulator here for some lower voltage rail. Couple of capacitors. It's not very well built, this thing. I mean, look at these, like, you know, like snaggle tooth things are somewhere stuck in there, yeah. And all in all, it doesn't seem to be very well built. I mean, it says 800 watt, but I doubt this is 800 watt RMS. 400 watts per channel. It could be, but I'm a bit dubious at that. Yeah, you can see if there's a rating on the main transformer, you can figure out what it is, because basically this transformer will be rated at double the output. So if this is like a 500 watt transformer, this is a 250 watt amplifier, total 125 per channel. Let's see. So there's not a lot in this, that's the truth of it. There's a little bit more. Looks like an LED that's bent here. Looks like a couple of input boards there, so the signal comes in here. It's fairly simple. So the first thing is, why is it not switching on, which is what he says. So I think we'll let's get a power lead. Let's connect this to the current limiter, because I don't know what condition this is in. And let's switch it on and let's see what happens. So my current limiter is here. It's just a light bulb in series with the main. So the main supply is coming via the light bulb. I've just set this to limit so I can bypass the light bulb or have it switched in circuit. This, by the way, is my Variac, but it's just turned up to maximum. You can possibly see it showing 220 volts on the Frankenstein style meters on there. Yeah. You know, those old Frankenstein labs. So that's on. This rather dodgy switch. I'm just going to... Okay, well, nothing happened. So I'm flicking the switch and nothing's actually happening. So it's like something's open circuit here. Is it a fuse? Let's have a look. So we'll just unplug the power, and then let's see if we can trace where the main circuitry comes in here. I mean, this is just a linear transformer, so it's going to go, I would have thought, via a fuse, possibly, the switch into this transformer. Let's see. I have the meter on ohms range continuity, not diode range, just ohms range, but with the bleeper on. So first of all, we can see what was behind my meter. This is where the power comes in. Now of course I've got the wires all tangled underneath it. It's a bit better. So we can go then from the power coming in. This is the blue wire. That should go to the switch. There's one blue wire. Yeah. So that goes to the switch. I'm just effectively just connecting to the switch. So we have continuity there. Then with the brown wire live, should go to the other side of the switch. Let's have a look, see what we have. Either I have a bad contact or it's not going there. Let's see. Okay, so I seem to have a problem there. Somebody's put this on back to front. So they've got one live wire coming in here on one side, and then the neutral wire is coming on this side. But that wouldn't actually matter, because all the switch does when you switch it, it connects the two blue together and the two brown together. So it doesn't specifically matter that they're on opposite corners. So that's switched on. So let's have a look if we got any continuity on the switch then. There's nothing there. The brown one. Oh, so I have something that, well, I did have. I'm going to disconnect this switch and let's have a look to see what we've got here. So let's get the switch and let's just zoom down a little bit. So this is our switch, we can see. And it's obviously not the original switch because it doesn't fit in properly. But it's now switched on. So you would assume that these two connections will be connecting together, and they're not. And you'd assume that these two connections are connecting together, and they're not. I'm pretty sure it would work that way. I mean, the other option, it goes across, but I don't think so. I've got a continuity, the meter's working. No, looks like a switch isn't working. Switch it to the off position. Definitely nothing there. Definitely nothing there. Let's switch it to the... No, that might be the off. This might be the on position. Ah, okay. So I now have continuity there and there. I should have continuity on the two on the other side as well. Oh, I don't know. Okay, so one pole of this switch isn't switching. I mean, we could if we were stuck and it was the only one and we have a bit of, you know, like a rush. We could effectively just get you to switch one pole. But let's see if I can find another switch that will actually maybe even fit into this. I'll have a look at my stash of salvage bits. Okay, I have a salvage one that's dual pole, double pole, single throw. That's the only one I have. I have quite a lot of single pole ones. So does this switch work? Let's have a look. So we set it to odd. It doesn't light up this one, but it might well work. So yeah, these two pins are connecting together, and then the ones on the other side should connect together. Yeah, they do. If you switch it off, they should disconnect. Yeah, it's disconnected. And this is disconnected, I think. So yeah. Okay, so that switch is working. And I'm pretty sure we can use this. This one almost fits in as well. In fact, this does fit. I can get this to fit. So I think we'll use this. So what we need to do first is get this heat shrink off and see if we can unsolder the wires and push these spade terminals on. So let's have a look to see, first of all, what's under here. Maybe just, yeah, along those pliers. It's obviously just been removed from something quite hastily, so yeah, there you go. Okay, so we have like a tab with some soldering. So if we remove the remnants of the wires off from this, we can probably clean up these spade terminals and push the connectors on. Okay, yes, that's off there. So let's get the soldering iron and let's just see if we can clean this up. So this is the one I'm going to fit. This is the one that came out. That surprisingly didn't seem to fit into the slot, although it appears to be the same size. So it looks like it has the same sort of terminals. I just need to desolder these bits of wire off it. Let's see if we can get in here. I might have to add, yeah, so it's not melting easily, so I'll probably have to add some leaded solder to this. Let's have a bit of flux as well. Flux never harms, so a bit of flux, a bit of leaded solder, and let's see if we can clean this up and reuse it. Okay, hold it down a little bit. Yeah, that's got it. See, the flux and the bit of leaded solder made all the difference there, yeah? Just blow the smoke away from me a little bit. Yeah, that was kind of like coming out through the middle. It's sort of gone, it's inside here. Yeah, it's going to come off, that's off. And then same on the other side, a little bit of flux, a little bit of solder. I like these sort of jobs because depending on what's wrong with this, you know, I can probably charge them a reasonable amount of money. It's going to cost you more money to go out and replace it. Plus, most certainly have to go up to the capital to get one, unless Power Sound is still trading. I don't know. We can let's have a look. And because you know these guys are busy running these bars, most likely they probably just want an easy solution, quick solution. Job done. Okay, let's just see if we can now clean this off, the excess solder. Let's go, it's going. Oh yeah, it's coming nice and clean. Right, I'll just carry on and do the rest of these, and then let's see if we can get the thing to fit. That looks probably clean enough now to use. So we'll just check this again. So they're fairly simple, these switches. So we just have effectively two terminals here, and when we switch the switch, they connect. Yeah, and the same on the other side. Two terminals connected, disconnected. They have like a plastic thing between two of the terminals. I think this is where the live and neutral come in, but I don't suppose it matters that much because once it's switched on, the live and neutral under the pair as well. So I'm not really sure exactly why they have the two close together with a little plastic divider. I'm guessing somebody can probably tell me. So I'm going to see if I can. I'm going to connect the incoming power on this one and the outgoing on this one. So let's zoom back out. Let's see if we can do it. Now I'm just going to identify the correct wires. So these two wires come from the power coming in. I can see that's these two. So these two are the power coming in, and the other two, yeah, I can see they're going to the transformer. So that's the out. So we'll take the two coming in. I'm going to try and connect them to this side of the switch, but I don't think it really matters. It doesn't matter electrically, that's for sure. But there they are, either side of the thing there. And then the other two can go here. So this is the output side. Okay. So we'll go, again, brown to brown. So the brown connects to the brown. Again, it doesn't really matter electrically because it's AC. So live and neutral, a bit of a, you know, a concept that doesn't matter to the flow of the electricity. It's more to do with the safety to the operator. But this thing's earthed inside, so it doesn't make a great deal of difference. The live and neutral just go to the transformer and nowhere else. But we'll put them like that. So live to live, neutral to neutral, and we'll switch it on. normally speaking, you put the on upwards. It's so that you can. The reason for this is so it's easy to accidentally knock it off, but not accidentally switch it on. That's supposedly the reason why the switch goes that way these days. I mean, at one time I think it was more common for it to go the other way. There's that little glass cover here, but looks like it should light up with two LEDs, one either side. So I just bent that back into place. And we can try this. So we now have a functioning switch. Let's see what happens now if we connect power. So I'm still connecting via the current limiter. There's a fuse in here. Yeah, but I'll just check it first. If it's still not powering up, let's check the fuse. But first, let's see if it actually powers up now. So we'll take the... When I find it, yep. Any power cable coming in. It's switched off on the front of the amplifier. That's in there. So let's switch this on now. Let's see what it actually does. Well, nothing lit up. The current limiter didn't flash. Nothing happened. And I thought, honestly, it would have. I thought that would have powered up. Let's see. Okay, so the next thing is the fuse then. Is the fuse blowing? So the fuse is in here. And I think the easiest way is probably just to take... I can either take the fuse out and check it, or I can measure the continuity from here to the switch. Well, let's just see if we can easily get the fuse out and check the fuse. That's coming out. Okay, let's see what state this is in. Well, it looks okay. It's not like blackened or anything like that. We'll take the meter. Let's have a look. So we have fuse is all right. Fuse is okay. So why is this thing not powering up? We'll reinsert this back into here. Looks like it goes this way around. Yep, looks like it goes this way. And it looks like it's a little bit harder to get in than it was to get out. Definitely goes this way round. Maybe I have to just make the fuse a little bit more centralised, maybe. Try that. Oh. I think the fuse holder might be damaged. Oh, that's interesting. That is interesting. So, now we know. This fuse is the spare fuse. The fuse actually goes into that slot, and the fuse is now in there broken, which might be because the way I took it out, but I think it's more likely it was just broken. Yeah, you see it down there, but that's the ends of the fuse. And it shouldn't just shatter when you take the thing out. Okay, there's bits of glass in here. Let's just clean that out. So that's there. So I'm looking at this now. This goes in this way up. Okay. And I think the fuse actually goes into here. The fuse that's in use. And this slot here is for a spare one. I'm sure I can put a spare fuse in this. I have them. Let's say hard to read. Use only with a 250 volt fuse. Yeah. What amps? What I think we really need to know, what's the ampage of the fuse? Oh yeah, it's gone back in. So that's in. I'm sure we can read the ampage from the fuse that's in there, or possibly from the broken end caps that I've just removed. Oh, these look like they've kind of... I'm going to show you. Let me just zoom this down. Actually, you know, I've decided to get the microscope because this is a bit interesting. This looks like it's almost been soldered in, or possibly welded itself in place. You can see the end of the fuse there. Okay. I think this fuse is like blown badly. Looks like this end's where the glass was. The other end looks like it's actually come off. It's blown off completely. And where's the one from the other end of the fuse? Here's the other one. And this also, well, yeah. See that somebody soldered this in at some time. Well, it's kind of like blown so much, it's kind of like, I don't know, this looks like a bit of wire. What rating is this? AL 250, there's so many amps. So 5 amp fuse, yeah, 5 amps. L 250. I think L is the amount of time it takes to blow, like time lag or something, compared with F for fast. Actually, you know, I'm not totally sure what the L is. I do with fuses. F a fast blow. I think T is like the slow blow, effectively one. You know, take a surge for a certain number of seconds or milliseconds. So I'm not sure about L, but I'm sure that it is something to do with how long the fuse will take to blow. So what we need to do now, I think, is just check the continuity of this. So if I come for, in fact, I'm going to use the mains lead. Okay, I have the mains lead, so I'm going to plug, it's not plugged in, I have the other end, I have the plug here. I'm going to plug that into the power, and then I can easily test now from the plug to the switch to see if I have continuity, if the fuse is any good, or the fuse holder. I mean, we know the fuse itself is okay. So we'll just go from one side of the fuse. Let's have a look. No, apparently we don't have. The other side. Oh, the power goes in on the bottom of this, so we need to switch it on. So it's switched on. And I still don't appear to have any continuity from here. Let's go into the blue there, so that should go to the blue here. Yeah, it does, just can't make a good contact. And then the other end must go to the brown there. It must go to the brown here. Yeah, so we now have continuity of power to the switch. So because that fuse seemed to have vaporized previously, let's connect it back together with the current limiter. Let's see what it does now. So I'll switch it off on the front, and I'll just put the meter. Sorry, I'll just put the camera where you can see the current limiter, the light bulb. It's up at the top of here. You'll see it light up. I mean, what you'd expect to happen when you switch on with a light bulb is it'll come on bright and then go dim. So it comes on bright while the main capacitor's charged, and because the amplifier is not effectively running, there's no input, you'd expect that to go dim. If there's a short somewhere, they'll come on and stay on. So let's see. So we can take the power now without knocking the camera out of line. Go. So take the power. Okay. I'll just tighten that up. It's like Captain Chaos today, I'm sorry. Okay, we're up. Are we? I think there should be an outtake, guys. Right. I have it. Solid. So I'm now going to switch on and see what happens with the light bulb, okay? Well, it came on bright then went out. That's normal. Oh, and we do have, this amplifier's on now. Can you see the blue LEDs are on? So it's now powering up. So that's the first thing sorted out. So the next thing we need to probably look at is the fan. And then once I've solved the fan, we'll see if we can get it working. It probably is working. He said it was working, just kept shutting down. And then it stopped working altogether, which I think I'll put down to being the switch and the problem with the fuse. Although I'm not quite sure. Do you know what I'm wondering? If like that switch wasn't the original switch, it didn't fit. And if somebody has replaced the switch because they thought it was broken and put these wires the wrong way round and blown the fuse, that sounds a very good possibility to me. Okay, let's see if we can sort out this fan. I've unplugged the power. I can see the fan has like a red and black wire. You can probably just see it down here. This wire amongst all the dirt. And it goes to here. So that goes to this board. I've just unplugged it. Yeah, see the wire moving. So we can get the fan off. I've disconnected the mains. So let's unbolt this fan and let's see what we can do with this. I've removed the fan and it's pretty solid, this is, to be honest. I don't think there's much point in trying to actually free this up. I mean, we could take the label off and probably get some oil into it. Yeah, there's like a little cap here. I mean, we can do this, but I'll probably end up replacing it, to be honest. But we can take the little cap off there and we can put a bit of oil in and we can see if it will actually free up. This is a common oil. In the UK they call this 3-in-1, as you can see, with the same logo. And of course it's Tres en Uno, yeah? But it's the same thing. So put a little spot in. Let's see if I can actually get this to 3. Yeah, it's not going very easily. We can also try the old WD-40 as well, and then some oil, and give that a go. We do have WD-40 here, but I've got some of this as well, much the same sort of thing. I keep the WD-40 in the van mainly for when I'm working on satellite dishes. The old ones get all rusted up. So we can try and wash some of the crap out of this. Let's see if it'll actually, yeah, you know, it isn't really going around any better than before. I could take the little clip off, being a little bit determined, and I swear I'm going to change this thing, but anyway, let's have a look. If we can get the little plastic clip off without damaging it too much. Come on, well, I think it's actually broke up a little bit, but we can have a go. Come out of there. Yeah, this is not going to come out easily. There, I've got it. Okay. I've kind of got it. Now I've got it. Okay, I've got a little plastic clip out, mostly in one piece. Probably enough in one piece we can actually put it back in. Can we get this thing to come apart now? Yeah, so we can now get it to come apart, and we could clean this out. So let's do this, and then I'll show you the other way to fix this as well. Let's see if we can actually make a decent job of cleaning this thing. Okay, so I've got all the dirt out of here basically, and we need to also get all the dirt out of here as well. And I think probably it's kind of got into like these little like metal sheets. This effectively is like a magnet, or an electromagnet I should say. So we can clean all that off. Probably get a bit of ISO actually and get this thing to clean up properly. Let's just so yeah, this comes out of here. Okay, just come out. Not easily. I was hoping that was just going to come out of there quite easily. Let's have a look. No, it doesn't come apart easily, but I can now clean it with this and then probably clean it with some ISO as well. One moment. I just did that over the dustbin. Saving it everywhere on my bench basically, so I'm going to clean with that. Now we can take some ISO. Get hold of that. And see if this will actually also clean this up. Brush. And I'd probably do well just to get, you know, enough of this ISO to actually just soak this in it, but I'm going to do it this way. This thing is now actually coming loose. Is it going to come off? Yeah, it is. There we go. That's good. Right. Now we can now clean this properly. Is that a good clean? Well, let's have a good clean. Let's give all this a good clean. Okay, and give all this a good clean. Then we can put some lubricant on it afterwards. The Tres en Uno, yeah. Nothing's funny about that to the Spanish. It's just funny to me because I'm English, yeah. Okay, so that's everything cleaned out of there. Okay. Now let it dry off, and then let's see what we can do with it. Okay, so I have all the various parts of it. Let's see if we can put this together, and will it now actually work? So we can just get this PCB into here. Yeah, that's clicked into place. The wire just goes through the back. Okay. And then we have the spindle. So I'm going to put a little bit of the 3-in-1 lubricant on this. I mean, WD-40 isn't actually a lubricant, it's a water dispersant. So you need to put a proper lubricant, just a little spot. There we go. On there, and this should now drop into the thing. Yeah, that dropped in cleanly. And now we have to put the little plastic clip back on, which normally is easier than getting it off was. So let's see if we can do it on camera. Yeah. Everything's harder on camera, by the way. Possibly use the needle nose pliers. If all else fails, I'll do it off camera because it's easier. That's a little bit of sods all. Okay. I've got it on there. Let's try the long nose pliers if they'll actually do it now. Push it from either side. Yeah. Yep, it's in there, yeah? See, you can do it on camera. Yeah, that's it. That's now running freely. So we can test this, and then we can look at the other method as well, and then you've got 2 ways to go about this. So that was one of them. Let's just connect some power and we'll try it. So these are just connected to my power supply set to 12 volts. Easy way to do this, if you haven't just got some probes to hand, is just to take, this is like a 10 meg ohm resistor. So at 12 volts this is practically open circuit. So we can just effectively stick either leg, just bend them into place. There we go. Okay. Try to keep it in the shot for you, of course. So we can stick this down into the connector like so, and now we can easily clip the leads on. So red to the positive, and now if we touch this should now spin. Yeah, that's running well, and it's running quiet as well. So that's working well. So we can use that. But the other thing I would suggest, this is obviously a CPU cooling fan. It's the same size as our fan, which has 4 wires. So with these, basically, the black wire is ground and the yellow wire is 12 volts. And then the green and blue, the green I think senses the rotation speed, and the blue controls the rotation speed with pulse width modulation. But if you just connect the power to the yellow and black, it will just spin full speed. So we can do that with this one. I might just try to actually just take the wires out of the little connector, make it easy while we do this, so I can show you. So you could do that. You could effectively just solder a couple longer wires onto the yellow and black. Take that out of here. You know, if it's not going to come, we just do it the other way. We just chop them off. Let's give it another. Let's give it another go so we get it to come out. Maybe something a little bit stronger than the tweezers. Yeah. Try this. See if this will do it. So push on there. Yeah, out it comes. Yeah, and we can always put them back in again. So again with the yellow one, push on there. Out it comes. So yellow will be 12 volts on one of these, and black will be ground. So we can do the same thing, just get rid of that resistor. So yellow there and black onto the black, and that's actually spinning better than the old one. Although I have repaired the old one, I'm much more tempted to use this. So it feels like it's got more airflow than this one. So we'll use this one anyway, but you've seen how to repair the other one, and also how to get the wire cut into the fan. I have taken the wire from the fan I just repaired actually, and effectively just extended the yellow and black. So can now plug this in onto the actual PCB, and then let's try the amplifier again and see if the fan's now working. Okay, it's ready to go, so let's see. Yeah, that's looking good, guys. So I can just fasten this wire out the way, and this is giving a lot more airflow than the original fan, so that's good. So okay, we can now fit that back into the amplifier. I will just mention, by the way, the original fan was 12 volts 0.15 of an amp, and this is 12 volts 0.19 of an amp. So it does take about 20% more power, but I honestly don't believe that, given the circuit here, is really going to cause a problem. I mean, there's a transistor down here that might be feeding it. I honestly think at such a low current, it's not going to cause a problem. But it's something to bear in mind if you are fitting a new fan, is whether the actual current is suitable. I've cleaned the worst of the dirt out of it now. I've put the fan back. I've just fastened this out of the way, so it's not going to get trapped in anything. So this is ready to try, so I'll connect it up and let's see if this is actually working. Okay guys, so it's all back together, kind of cleaned, and it's time to try this now. Fan's a little bit noisy, but this thing makes plenty of sound, I would imagine, when it's running, so I don't think that's going to be a problem. So let's try some funky music. Yeah, let's see what Dickie's got today. There we go. Definitely working. I think we can definitely say that's working. Okay guys, so we'll call that a success. I'll test it, yeah, I'll test it. Where's the dance floor? Okay guys, see you all soon on another Learn Electronics Repair video. Ciao for now.